Okay, so then I will record that meeting and I will make that available afterwards also to you all. Cool. Now, as of today's agenda, we reserved about 90 minutes, maybe with the possibility to extend to 2 hours if that's needed. So the idea was to give a quick introduction on SiLA 2. And then Georg and Mark will give a introduction into the C# and the Python repository, respectively. So I assume you can see my screen well. I have not answered that. Yeah, perfect. Okay, so what I'm going to do is I really like to spend maximum 30 minutes for the SiLA 2 introduction, ideally. So I have a pretty large slide deck for that, and I will skip many of the slides, but the slides are all available to you. I think you all have the link to this document here, to the Hackathon 19 agenda, and if you click on that link, you basically get to that this document here, which really has a lot of slides about SiLA and a digital lab in general, giving basically also a rationale and telling a whole history why SiLA and why standards are important. And so please bear with me. I will skip some of the slides quickly. You can afterwards look at that if you want. Still, I wanted to start very, very briefly with why things like SiLA are very important for the digital lab. You probably heard a lot about digitalization lately. You heard a lot about probably things like machine learning and artificial intelligence and data lakes and whatever. And I am a strong believer, and I think I have many friends with that. I'm a strong believer that data standards and communication standards like SiLA and maybe also Animal or Allotrop and other stuff is ultimately vital for actually digitalizing the lab. But things like SiLA or Animal or Allotrop are not a solution for your digital lab, but I think they are a necessary condition to actually be able to digitalize your lab. So this is just to give you a bit of the background why actually we were doing SiLA 2 and why SiLA is also supporting other initiatives. You will learn that in a minute. So just as a part of the introduction, I mean, in an ideal world, all these heterogeneous zoo of devices and stuff in a lab would be able to talk to each other, right? So would be able to basically interconnect. I think this is easy to understand. And then, of course, the digitally transformed lab is important, for instance, if you are in a regulated environment, to get rid of manual transcriptions, so you don't have any QC checks necessary to increase data integrity, right? You don't want to have paper, you want to have ad hoc setup, things to just connect, right? And in the end, the data, I mean, those guys from NIME mentioned the data part of it. In the end, it's a lot about fair data, so making data findable, interoperable, accessible, reusable, and things like SiLA and also Animal and other standards help to make your data fair. But not all the components of fair are actually implemented by applying standards. Yeah, but many of these concepts of the fair initiative are basically built when you base your stuff on standard, but not everything, right? Just to give maybe a bit of background and also a rationale about why we did SiLA. You probably all have seen integration of lab devices in a file-based way. You have a lab device that creates a file that is put on a folder, and another system is pulling a folder to read the file. And the problem with this approach is not only the proprietary file formats, but also access permission issues with race conditions. Is the file already written? Has the operating system cached writing? And is the one who is reading it actually reading doing a current read and things like that? There is a lot of problems involved with that. Still, many lab device integrations are done file-based and also based on very old hardware interfaces like RS-232. And here as well, of course, you have proprietary protocols and formats. It's very difficult to maintain that in a big system. And for me, it's very important that you understand that SiLA is not a replacement of RS-232. Very often I hear people saying, "Oh yeah, SiLA is just another form of interface," and this is not true. You will learn that in a minute. SiLA is covering much more than just replacing RS-232. Actually, SiLA is even not going to that level. I mean, RS-232 is really a hardware interface mainly, and SiLA is really not going that far down. You will see that SiLA is relying on TCP/IP, and if you are familiar with the OSI levels and layers of network infrastructure, SiLA is only on layer 7 and above. We don't go anywhere down there. And if you talk about RS-232, this is probably on OSI layer 0 or maybe 1, right? And we're not going that far down. And that's important maybe to understand. But this is a bit of the rationale. So in the end, what we expect in labs today and what people expect is zero configuration, seamless integration. It just works. And exactly this is the vision of SiLA. The vision of SiLA is you go to Sartorius, and we mention now Sartorius and not the competition because we have Sartorius in the line. You go to Sartorius, buy a balance, you go to an ELN vendor, buy an ELN, and these things just connect like your Bluetooth headset connects to your mobile phone. This is the vision of SiLA, right? Just zero configuration, interoperability inside the labs. Now, to do that, you need to have standards to basically describe capabilities, standards to find services, find each other, and standards to basically orchestrate or command each other, right? So once you can imagine, you have your balance, you have your spectrophotometer, you have your HPLC, you have your pH meter and whatever. These things need to be able to describe themselves. What can they do? What data formats they support? And the standard needs to be so powerful that it allows you to kind of orchestrate these things in various manners. Master slave, peer-to-peer, whatever. And SiLA is exactly doing that. You will see that in a minute. And SiLA is also not enforcing you into any specific model of application. You will also see that later on. Now, why are software or why are these standards not there already? Why is the lab still 30 years behind? Why is the lab still using RS-232 or virtualized COM ports over USB and things like that? I mean, my personal opinion is that this is very manifold, or there's many reasons for that. I think definitely one important reason is that pharma just has enough money to pay for integration projects all over again. Yeah. In contrast to automotive industry, the margins in pharma are 30% plus, and therefore it's just not necessary. You need standards. And in automotive industry, if you are a vendor and you buy you sell your components without supporting a standard, you're probably out of the game. But in the life science industry, if you sell your mass spectrophotometer or your whatever your GCMS or your whatever stuff, you are still able to sell that even if you don't support any standard. And if you save your files in proprietary formats and whatever, you're still able to sell your instruments because scientists probably still like to buy your product because your product is the most advanced mass spec that you can find, whatever. And the other thing is software standards are really not tangible. If you compare to microtiter plates or container logistics, these things are just tangible. And I think everybody of you understands why standards make sense, right? But with software, sometimes it's not that obvious. And this citation I also like a lot. In the lab, we are far away from that. So as a conclusion, to basically do true integration in labs, you need to have communication standards and data standards. Now, talking about communication standards, we're talking about SiLA. And talking about data standards, we're talking about animal and allotrope and stuff that I mentioned. All of these things are in this slide deck here. You find more information. I will not go into the details of everything. It's important to understand that SiLA is mainly a communication standard, but SiLA also allows you to model data, right? But just imagine if you want to use SiLA to talk to a camera and the camera sends you an image, you would probably be stupid to use SiLA to model the image format, right? You would probably use JPEG, or you would use whatever format or video format or streaming format, which is already exists, right? It's very obvious for images. Yeah, if you talk about analytical data, you could use SiLA to model a spectrum or a chromatogram, but you would be stupid because you could use NEML, which is the analytical instrument markup language, to basically model your data. It's just use what makes sense. And of course, with SiLA, we focus on the communication. So basically on finding services, connecting to the services, finding out what these services can do, and work with these services. Yeah, and you have heard the word service a lot. SiLA is a lot about services, a lot about systems and instruments, devices offering services. Yeah, like a balance offering a weighing service, and a LIMS system or an electronic lab notebook, which is using these services, right? And of course, there is always, if you talk about services in a lab, you always talk about data as well, because usually you talk to analytical instruments or instruments that produce data in any form. And of course, then data standards are also important. But as I said before, SiLA does not reinvent the wheel. So like with the hardware connection, SiLA did not invent the hardware connector, but SiLA said, okay, let's base on TCP, IP, and Ethernet and things like that. Because we think it's stupid to reinvent stuff which is there. And this is the same for data formats. SiLA does not invent any or reinvent any data formats, right? Okay, so, and then if you talk about data standards, you hear, especially in Germany, you also hear a lot about OPC, which I don't go into details now. And you hear a lot about SiLA, and SiLA is really emerging in that area. And SiLA is the thing that we're going to focus. Now, the next couple of slides I'm going to skip, because these next couple of slides are about fair data, about NML, about allotrope, about HL7 fire, about Pistoia Alliance, about C-disk, LOINC, and all these things. We're not covering that today. Well, what I like to conclude here is, I'm sorry about the formatting, that for true integration in a lab, you require two things. And our recommendation is, of course, that you use SiLA as a communication standard. And if you're talking about an analytical lab or a bio lab, that you use NML for the data side, right? This is the recommendation of SiLA because it just makes a lot of sense in terms of business model, licensing model, etc. Openness, Animal and is as open as SiLA, it's as royalty free as SiLA, so that just, it makes sense. It's maybe important for you to understand that you also could use allotrope or any other format to transport over SiLA. But just from a business model, it doesn't really make sense because you have to pay a lot if you want to use allotrope, right? And it just doesn't match. And this is basically our rationale. Now, if we come to SiLA, you all know that probably that SiLA is a non-profit organization. And it's important for you to understand you can be member. Of course, we would like you to be member, or we would like you to be paying member, not only personal member, because SiLA is a non-profit organization and we need money from paying members to run the operation. We need money to move forward the standard, to keep up the quality of the code repositories, even though the code repositories are not the standard, but they are important. Yeah, you know, the code repositories are important for you to get access, etc. But it's important to understand that the SiLA organization is actually just defining the standard. And what is important for you to know as well, that everything that SiLA produces is free of charge and available to anyone. You don't need to be member to use it, but you need to be member if you want to take part of decisions, right? If you want to be able to ballot for new additions to the standard, if you want to be able to vote for the roadmap, etc., you need to be member. But you don't need to be member to contribute on the Git repositories. You don't need to be member to use the standard. And there is no licenses, no license fees or royalties. And I think this makes it quite nice to use. Now, what SiLA was basically intention, you all know that SiLA 1 has been around for 10 years at least. 2008, 9, the first versions were there. But SiLA 1 was never really successful in terms that it was widespread and really used in a wide manner. And there were several reasons. Of course, technical reasons because of the chosen technology of SiLA 1, but especially organizational reasons. And in SiLA 2, we really changed the openness, the way how SiLA is developed, the way how the standard is developed to a very much open and community-driven process. And because of that, people are using it. I heard people saying, hey, I don't know whether SiLA 2 is maybe really the best technology or whether there might be better ones. But the fact that SiLA 2 has been continuously developed over the last 4 years by many people, publicly visible in the community, is for me a very good reason to use it. Yeah, because I know there is people actually doing. Now, if you go a bit into what is SiLA, you can imagine SiLA in its easiest form as a combination of a server and a client. And talking about the internet, the SiLA server would be the web server and the SiLA client would be the web browser you use. So if you use a browser to navigate to whatever, to your favorite web page, you basically do exactly what SiLA is doing actually in communication. So the SiLA client is actually doing creating a connection to a SiLA server, and the operational model and the coupling is like in a web browser, web server context. You all know that the internet might be unstable, might be slow, you might have mobile connections, you might connect to a server and then be interrupted and reconnect, etc. And it just works, you know, your website works even if the connection is bad. And this is exactly what SiLA is also doing in its design. So SiLA is very, very tolerant to slow networks, bad networks, interruptions, etc. SiLA is very stateless, and this is one of the main, I think, principles. And this is a big difference to SiLA 1. SiLA 1 was very tightly coupled. If the network was bad, you would have a problem, etc. And SiLA 2 is not. Now, main components of SiLA are the discovery components. So a client can basically discover what's out there. Discovery mechanisms are the same mechanisms as, for instance, Apple uses to find air printers or air players, right? You know, if you want to connect your mobile to your TV, to your Apple TV, you use the same mechanisms that SiLA is using. And the discovery allows you to not only find who is there, but it also allows you to find out what these different parties offer. So you find a balance maybe, and this balance can tell you it offers a calibration service, a weighing service, there is a monitoring service, there is maybe a service for qualification, and this service describe themselves. And now we are at the feature concept, and this is extremely important in SiLA. So everything a SiLA server wants to offer, so if you are a whatever type of service, everything you offer, you describe using SiLA features. And the SiLA standard describes a feature definition language. And this feature definition language basically allows you to describe the capabilities, data models, interaction models, etc., of your service. This example here shows a balance that offers different services. The SiLA service is a mandatory service every SiLA server has to offer. And the SiLA service is general information about the server, right? And then this balance offers a weighing, a calibration, a monitoring, and a qualification service. And each of these services are self-describing and are described using the feature definition language. We hear that later on, but this is important to memorize. Features are the most important component of SiLA. And this is also really what makes a difference to any other IoT standards or whatever is out there. This is, I think, pretty unique and really made for the lab or life science domain. I skipped the next example of the HPLC because it's similar, but it's important to understand that the feature framework is really a central component which describes the ontology and taxonomy of the services and the offerings. Features are very lightweight to maintain. You can imagine that services evolve. So services have to be versioned. Service there will be new versions of the weighing service, and SiLA puts a lot of effort into forwards and backwards compatibility. So that once you have client-server interactions, that these forward and backward compatibility is given. You can imagine, like if you're using Microsoft Word, if you're writing a document in Word 2007, you can open it in Word 2013. If you write it in 2013, you can open it in 2007. And it works backwards and forwards. And it's very well defined what happens if several features are used in in 2013, which are not available in 2007, you will see that as a user. It's a so-called failed fast type of approach, and SiLA is doing actually exactly the same. Then features, and this is the interesting thing, features can really be your vendor-specific proprietary thing in your namespace. But features can also be standardized. Features have a so-called maturity level from draft to basically normative. And features can also coexist, not only different features, but also the same versions of the same feature can coexist at the same time. And I think this is an important aspect. And this was, for instance, an important learning from SiLA 1. For those who did SiLA 1 used device classes, which were extremely strict and unflexible. And if a vendor wanted to basically create a SiLA interface for his specific new device, fancy new device, very often these functionalities were not built into the device classes. So what did the vendors do? They used an escape route, which was in SiLA 1 a so-called specific command. And then they were adding specific commands, which were total crap because they were basically a side of the standard and were not the standard. And with SiLA 2, it's totally different. If you as a vendor have your newest fancy new thing you want to have marketed with the SiLA interface, you create your own proprietary feature. But because of the feature definition language, any other party will understand, right? Even if the feature is proprietary, the feature definition language will make it totally transparent what it is. And even a SiLA client, which has not seen your device before, can use it right away. And this is, I think, the beauty of SiLA 2 and the feature concept. Now, you can imagine a company like Sartorius creating a weighing feature can have an interest to make this weighing feature a standard. Okay, and then you need to be a member to basically be able to propose a feature as a standard feature and to be able to vote and ballot on this feature to make it part of the standard. Yeah, but you don't have to. But this is a possibility. So that's why the feature framework is really, really, really central. Now, once you imagine you have a LIMS system who wants to orchestrate a balance in an HPLC, right? So the LIMS on the right side has different workflow tasks from identification to tearing, weighing, preparing a sample set, and analyzing and retrieve results. And the LIMS would use these features as a client and operate the different services, weighing services, management services, sample submission service, whatever, to actually orchestrate. And now what is important to understand, I mentioned that before, SiLA does not force you into an application model. I mean, this is a classical master-slave approach. You have a master LIMS orchestrating devices, but SiLA does not force you into that. You can also swap the roles. Yeah, you can have a LIMS or a laboratory execution system, in this case here, offering services to find out what tests do I have to do, what sample context exists, what do I have to do, right? And then you have the barcode scanner or the balance here, which are the clients, which are actually asking the LIMS, okay, please give me the next test. Okay, LIMS, now I have a result. Can you please store that, right? And so the roles have swapped. And SiLA is not enforcing any of these models. SiLA can really do even peer-to-peer communication. Yeah, it was very important for us in the design of SiLA that you don't need to have a broken server somewhere. In theory, you can have two standalone devices that directly talk to each other through SiLA. You don't need to have a physical server somewhere, right? In terms of a server PC, right? Yeah, you don't need to have a central broker instance or so. You can, but you don't have to, right? And so this is just giving you an intro how the SiLA operation models work. So in the end, you can have even a balance can be a SiLA client and a server at the same time. So the balance can offer stuff, but it can also be a client and use SiLA stuff, right? And so this is the very important thing. Now, I wanted to come into the conclusions and summary. Before doing that, I wanted to say a few words about the technical specification. You have probably all seen that SiLA is a multi-part specification split in parts A, B, and C. So why is that? So there is several reasons for that. But first of all, the part A has been created technology agnostic, providing an overview of the concepts and especially describing the feature framework and the discovery framework. Part B is the actual mapping to an actual technology, the actual implementation. And part C is list and collection of features. Now, why is that? We have done that is we have a stable core which makes up the standard, and you have a very flexible part for evolution extension, which was missing in SiLA 1 a lot. And there is additional things. SiLA 1, you know, that has been based on XML SOAP web services, which were kind of considered deprecated quite quickly, and developers don't like it for several reasons, which I don't necessarily share all of them, but it's just the case. But we said, let's do things. Let's base on a technology which is probably lasting for the next 1 or 2 decades, hopefully. But also let's create a standard in a way that the technology could be changed in the future, right? And that's why we split in part A and B. But still, A and B are the stable core, and the flexible extension and evolution is part C. Now, technology-wise, I want to come to a summary and then mention a few words about the technical summary. So in the end, SiLA is a microservice architecture. Now, it's like RESTful web services, but it's not. It's not using HTTP 1.1, and it's not using JSON. Why? HTTP 1.1 has a big problem. If you want to have multiple interactions between your client and server, you always have to reopen and close TCP connections, which is expensive, right? So SiLA 2 is based on HTTP 2, which uses one TCP connection, and inside that TCP connection, you can have multiple streams of non-blocking communication. That's a big plus. Then HTTP 2 is based on binary headers and not ASCII headers, so it's much more efficient. And then as a payload, we don't use JSON because JSON has 2 problems. I mean, first of all, it's expensive over the wire because it's ASCII usually. But the bigger problem is JSON is usually not type safe because there is no such thing as JSON schema, which is actually a standard. Yeah, there is several approaches of JSON schema, but there is not really a standard. So JSON is not type safe. JSON doesn't really enforce you to use a point or a dot or a comma as decimal separator. That is the easiest thing, right? Do you send 1.5 milligram or 1.5 milligram? JSON is just not doing that, and you have to deal with a lot of problems due to that. So that's why SiLA decided to use protocol buffers. Protocol buffers are to be used like JSON as a programmer. As a programmer, it's similar. It's the same as if you would build a JSON object, you build a protocol buffer object and serialize it over the wire. But the serialization format is extremely efficient because it's binary and it's not human readable text. It's not, it's very, very much more compact, right? What is also important to maybe briefly understand is that the feature definition language is XML based. This is just the language we use to define the features. There is SiLA data type, the discovery, and server discovery based on zero config. Now, you have seen HTTP 2, you have seen protocol buffers, and maybe you have noticed the word gRPC, which is basically stands for gRPC remote procedure call. And this is a framework which is actually using HTTP 2 and protocol buffers for its communication. So now I get many questions. What is the relation then between SiLA and gRPC? So it's important to understand that SiLA does not have a dependency really. So the SiLA standard does not have a dependency on the gRPC libraries. SiLA has an only dependency on the gRPC wire format. The gRPC wire format basically defines how data is transported over the wire, right? And of course, we said, hey, SiLA is still a small organization. SiLA cannot afford to create very nice libraries to use the standard, right? But very nice libraries are really important so that the standard is adopted. Okay, so we have actually a double plus. We only rely on the wire format of gRPC, but we have a huge gRPC community and a huge set of libraries in 20 different languages, which are available already for gRPC, which help us to build the SiLA layer on top. So I think this is the decision. This is basically the rationale behind the decision. Okay, so we have a good technology choice, HTTP 2, which probably will last for 1 or 2 decades because HTTP 1 HTTP 1.1, I think, was started in 1999 and it lasted 20 years. And so we hope that HTTP2 is also lasting for 20 years. And then we have a big community for gRPC, which helps us implementing the library. We have only little dependency to another organization like gRPC, right? The dependency is only on the wire format. So in theory, we could rewrite the SiLA libraries without gRPC libraries pretty easily, but of course we would be stupid if we did that. Yeah, but this is to understand the context. So then my last slide I wanted to show is the conceptual summary, stable core for interoperability, the science aspects, physical units, concepts, relation with animal, the flexible feature concept. The feature concept is also kind of really a glue, building a kind of something building the bridge between the scientist and the programmer. It replaces a functional specification, yeah, that you would maybe otherwise write in Word and in Prosa. It replaces a functional spec, and the discovery really allows you to create self-descripting services, right? So, and now I spent my 30 minutes. I was planning. The next couple of slides are about animal. I will skip these here, but you can see that animal is very similarly organized. The animal data model is easy. Animal has a very simple and similar context to SiLA. Yeah, it also bases on very same concepts. And you also see here a bit of summary on animal. You can read that separate. We can have separate calls if you want about that. It's not the topic of today. Now I would say we would have time for 1 or 2 questions and then hand over to either Georg or Mark, whoever wants to be first. No questions?
One question from me. Can you make me a presenter?
Okay, I will do that. I hope it was okay. I mean, I know it was fast. It was a lot of information, but it's difficult to describe something you have been working on for 5 years in 30 minutes. But I hope I was able to transport the main rationale why we do SiLA. Why is it important? Yeah, and now we can go into the technical part. Okay, I will. Wait a sec. Georg. Whoop. Now you should be presenter. Go ahead.
Maybe one quick comment. So if you have questions to Daniel's talk now or to Georg's or Mark's talk later, you can also write down your questions in the chat, and then we will answer them after the talks.
Perfect, thank you.
Yeah, and then from my side, hello to everybody. So I'm going to talk about the C# repositories. So as you can see, it's not singular. And that is because there's actually 2 repositories. So one is part of the open source reference implementations. There's one for SiLA base, where all the schema definitions are. One for SiLA Java, one for Python. In the meantime, there's also a reference repository for C++ and JavaScript. And of course, there's also one for SiLA C#. They are free to use for.
Georg.
Yeah.
The slides that you're showing here, can you also maybe add the link directly into the hackathon agenda afterwards so that everybody has
I can put the link afterwards.
Thanks.
Yeah. But as CCAN, we basically decided that we also create a new reference or a new implementation for SiLA 2. And at the moment they do, so basically we have 2 coexisting repositories. One is SiLA C# and one is SiLA Tcan. SiLA Tcan is also open source, it's BSD 3, so also free to use for anyone, and contributions are also welcomed. So Daniel has also already talked a bit about the feature definitions. And how they are look in XML, and this is basically how such a feature would look like. So you basically on the XML side you have something like identifiers, display names, descriptions of a feature, and then you have a range of commands and properties, and define execution errors. And what part B of the standard actually does, it defines clearly how to map such a feature into proto files. and then can be generated automatically. There's a code generator from the SiLA Java repository that is used also in the other repositories to basically turn such a feature definition into a proto file. And basically then the feature is mapped to a gRPC service within such a proto file. A command is basically a service or a range of services for in this proto file. The command parameters are turned into protobuf messages. The command responses are turned into protobuf messages. Properties are turned into RPCs, and data types are also turned into protobuf messages, basically. So, and then what the workflow looks like is actually in the SiLA C# repository that you really start with the feature. So you start with this XML file, and create this XML file. From this, you basically have the code generator that generates you the protobuf file out of it. So all the RPCs that you need to implement for a given feature. Then you use the proto compiler to generate gRPC stubs for the client and the server. And then if you want to create a server, then you basically take the stubs for the server, implement those stubs, and yeah, basically you have a library which is basically the SiLA C# library. That you can then give this this implementation of the stub into, and this will start you the SiLA 2 server. Or if you want to write a client, then you basically take the generated gRPC stub for the client and you interact with that client. For SiLA, the Tican SiLA 2 SDK has a bit different, slightly more involved process, I would say. Here we basically don't start with a feature, we start with an interface, so really with the .NET interface. And if you want to create a server, you create the interface manually, and then you implement the interface as you would do normally. And then there is a specific SiLA code generator, and that will create the feature. It will create data transfer objects that have the annotations to put that on the protobuf, and it will create a service provider. So the feature definition that you saw at the beginning, this is actually generated, and also the provider, so the glue code basically to expose the implementation of that interface to SiLA is also being generated. There's of course a reference to some common parts from the SDK, but the actual mapping is generated. So the glue code how to expose that on the wire. The SDK also, on the other hand, also consists of a range of generic feature implementations. So there's, for example, a generic implementation of locking. There's a generic implementation of authentication, authorization. And at the moment, for example, there's also a generic implementation of cancellation. And you basically just, well, if you think you need it, you just reference your appropriate library and you're good. Even for cross-cutting things, like, I mean, for locking, obviously, this is like, okay, if there's a lock, then you can pass, and if you don't have a lock identifier specified, then you would abort any command where locking is required. For the client, the workflow is completely different, because for the client, you would start usually with a feature definition, and then you would use the same code generator actually to generate from the feature the interface out of the feature definition, and generate a code that would actually fulfill this interface using SiLA 2. So basically delegating all calls to SiLA 2 server that you specified using a given connection. But there's also a dynamic client that's contained in the SDK, which is free. So what you can do there is basically that you connect to a server, you ask the server what features it exposes. You can do that also, of course, also with SiLA C#. But then the good thing is that you can really go through the features, identify the features by name that you stored somewhere, and then create a dynamic request object, and basically execute commands and properties dynamically, so you don't have to know these features ahead of time. We use that for our instruments, so that you can actually mix and match whatever you like. So for our instrument drivers, for example, we have a couple of features that we take for given, basically. For example, things like locking. We know pretty well what locking actually means, and there we have a type safe generated client. And then for the others, so if a vendor decides that he has a completely proprietary feature description of his device, then we have a dynamic client, because we don't want to we don't want to know this feature in advance, such that we can also basically we can develop an integration of SiLA 2 devices without knowing what the devices actually can do. And we then show that to the user, hey, this device has the following commands, which we read from the feature definition. Which of those commands would you like to include into your automation script? And this is one thing where SiLA really helps a lot, because you can actually you don't have to know what features are there. You can actually implement an integration of devices that you don't know and that may not even exist the day you write the integration. Yeah. And this, we actually noticed that this workflow also for the servers. So what happens if you have if you want to create a server and the feature already exists because it's being standardized? Yeah, in that case, you just turn those two arrows around and take the feature definition and generate the interface and the SiLA server out of it. That's also possible. And one thing that I noticed is that in .NET we have the general problem that we have .NET 5 coming, and a lot of legacy applications use WCF, which is no longer supported with .NET 5. And what Microsoft is suggesting is to use gRPC, and they would basically recommend to use the start with the Porto files. But we noticed that our developers they have no idea of Porto files, but they do have an idea of .NET interfaces. So we are actually thinking really about converting all our WCF communication. So even this kind of communication that is not going to be exposed directly, even use SiLA 2 there, because we can. It suits nicely with the workflow that we know from WCF. Because in WCF, you also have the .NET interface. You start with the .NET interface. Which is the very easy part, and then in WCF you usually have the binding configuration, like whether you want this communication to be done via named pipes or TCP or web services or whatever. This is usually the really difficult part, and this is basically taken away because the binding is pretty clear, namely it's SiLA 2, and everything there is properly defined. So you have the good thing transferred, but you don't have the bad things transferred. Namely, you can really specify the interface and be fine with it. Yeah. In C#, in the SiLA C#, how it looks like from the classes is that you really start with the features. Then you have a class for a SiLA 2 server. That I should probably have this slide beforehand. Sorry. You have a class for the SiLA 2 server that really manages the implementation. Then which is in the library, and then you create your own server class that inherits from the SiLA 2 server class, and then has some references to implementations of the generated gRPC stubs. And at the client, you basically have your client that references the gRPC stubs directly. Yeah, and then in SiLA Tcon, we actually don't want to have those inheritance relation, because we favor composition over inheritance. And we use dependency injection a lot, and we have also the SiLA Tcon repository uses the Tcon internal logging contracts. So those are two reasons why you would still also want to use the SiLA C# repository, because if you don't want to use dependency injection, especially the flavor that we are using math, or if you don't want to stick to our logging contracts, then it would be better to align with the SiLA C# repository. If you are okay with that and you like the workflow better of the SiLA Tchan repository, then the SiLA Tchan repository would probably better suit your needs. For both repositories, there are tutorials how to create simple servers. Unfortunately, I'm not sure about whether there are good tutorials to write clients. But I mean, those two links will get you to the tutorials, where there's a detailed step-by-step description of what you have to do in order to create a first SiLA 2 server. As I said, the workflow is for SiLA C#. You start with the feature, so you write the feature how you want to expose your functionality. Then you generate the photos and the stubs from this feature. Then you implement the feature behavior using the stubs, and then you implement the server application and bind it all together. With SiLA Tchan, you start writing with a WAR interface without having any reference to SiLA 2, actually, completely separate. Then you annotate the interface, like what mapping do you want to have for the parameters, for example, which content types they should have, what ranges they should have, whether there's any well, if you have observable commands, you have to use some extra interfaces, but other than that, you basically put some annotations, and then you implement the interface also without having any reference to SiLA 2, and then you basically generate the glue code. And this is completely automated process. Yeah. So if you're interested into developing a SiLA 2 server with .NET, I would urge you to try one of those tutorials with whichever repository you like. Both of them are open source. Both of them are still maintained. Yeah. And that actually my presentation. So yeah, I do think we have time for a couple of questions, if you have some.
Maybe one note from me.
Mm-hmm. Yep.
Regarding the client development, you mentioned that there are not usable tutorials or something like that for developing clients. I would recommend to just look into the SiLA C# repository, and there are a lot of examples, and the examples always contains a server and the client, and then you can look how the client is developed in the sense that a client just basically uses the stubs, as you explained before. So you just call the methods in the stubs to send the requests to the server. So it's fairly easy, and yeah, if you have a look at the examples, then you will find a way.
Maybe you can also mention the SiLA browser quickly. I think it's referenced in the wiki as well. So the SiLA browser is actually a generic client that can be easily installed and used to basically test your service. It's automatically using SiLA Discovery and basically introspects the features, creates a graphical user interface, so you can run your functions actually on the SiLA server directly. I think for testing purposes, it's quite handy to do that.
Yep.
I do have a rather high-level question.
Yes,
you mentioned SiLA automation scripts. This is honestly something, I mean, how does it work? We mentioned, Daniel mentioned the browser just now. I mean, how does it look like in practice, tying together functionality from different servers? I mean, how do people do that in practice nowadays?
The automation script that I was referring to was using the control application of our instruments, basically. And what we develop at the moment is basically developing a generic SiLA 2 driver for it, so that you can actually have basically commands that you can create from inside those scripts. So I don't know whether if you've ever seen an application like Fluent Control that is able to control our Fluent instrument. There you basically have a graphical scripting language. And what the driver basically does is if you basically have a SiLA 2 connection to let's say a balance, and this has a weighing service, then from this we basically read the commands that are available in this weighing service, and then generate a command into the scripting language like weigh on this balance. And you can actually use this commands together with some generic and given commands, and of course the commands that actually control our own instrument, and then create scripts. And that allows you to basically say, okay, I want to have a for loop, and in each iteration of that loop, I first have a command to transfer a plate from somewhere in maybe even a carousel or a stacker or wherever, transfer that to the balance, and then I have the command that is provided to me via the generic SiLA 2 driver, where I basically say, okay, I call, which gives me a weigh command for the balance, and this basically uses then SiLA 2 to execute this weigh command of the weighing service in the balance, and get me the result. I write that into some variable that I have locally in the script, and then afterwards I probably take the plate away from the balance. That would make sense. And write down, do whatever with the result, and put it into some file or whatever, basically.
Georg, maybe I mean, this is a TechCon proprietary way, but maybe while I speak, can you quickly open up the GitLab page, and then of course this is what we call also orchestration of devices. You know, I had that before in my part of the presentation, and currently SiLA does not specify anything in the standard regarding orchestration. But if you look on the SiLA 2 Git page, maybe one up. Yeah, so there is, it's a bit hard to read, very small. There is repositories, thank you. Where is it? Oh, is it not, you're not logged in, are you?
I think I am, yeah.
You am.
Are you searching for the Camunda plugin?
Yeah.
Yeah,
it's
that's
under vendors.
Oh, it's in vendors. Oh, I'm sorry. Okay, so you were right. I'm sorry. Yeah, so SiLA Camunda is one thing. Maybe you have heard about BPMN, so Business Process Modeling Notation. And Camunda is a open source project which allows you to basically create business processes in a graphical user interface using BPMN. But Camunda also features the execution of a business process. Now, the cool thing about the SiLA Camunda is it uses SiLA introspection. It uses the discovery mechanisms to find all the services and capabilities, making these capabilities graphically available. You put this into a workflow and execute this workflow using SiLA. Right now, the SiLA Camunda project is not production ready, but there is production ready components, for instance, from a company called Unite Lab in Basel, who have a software which is called Unite Flow, which is actually using the same principles in the background, which allows you to use SiLA discovery, find everything which is in your neighborhood, and you can then graphically put the things together in a workflow and execute it. And I think this is a great thing. As I said before, currently it's not part of the standard on its own, but it's part of the ecosystem, of course. And I think these orchestration components are a very important part if you want to link instruments to, for instance, with a LIMS system. Usually in a LIMS systems, you don't want to detail a workflow, right? In the LIMS systems, you only have your test and your specification maybe, right? But you need to have an orchestration system as a middle layer between your LIMS and your instruments. And the SiLA Communda and other initiatives that are around are exactly covering that orchestration part. And in the end, the SiLA Communda is nothing else than a SiLA client, actually orchestrating the devices, very much like Georg just described it for the Tecan scripting environment, right? You could also imagine that you could create whatever, a JavaScript library, which is actually using SiLA Discovery and then makes SiLA devices scriptable. I know that these were the guys, I think, from FZ Jülich, who did scripting environments based on Python. I know that at one of the last hackathons, a guy was using Jupyter notebooks to basically run and orchestrate SiLA devices. So there is many ways to do that. And yeah, depending on what you want to do, one or the other is, of course, better.
If you want to create such an integration yourself, then I can recommend you to use a dynamic client that's in a Tecan SiLA SDK, because actually the integration that we have into our instruments, so this driver that I was telling, this is basically just like you memorizing which features you wanted to access using a static model and then providing some nice UI to it. But in the core, there's just a dynamic client that basically says, okay, at this point here in the workflow, I remember I had to call this command of this feature of this server, and the server is identified using its UUID. So I can find that even if it changes the IP address or anything. And then, yeah, just go and call that service. Here is how you have to construct the request out of the current, yeah, basically variable setting. And so this part is basically the integration, but the actual calling of the service, this is actually part of the open source repository.
Thank you. That was really the missing piece in my mental model. Thanks.
Yep. The only thing that you also have to consider is the client. It's usually not sufficient to just know how to create the request object, because you also have to think about metadata, because some features have cross-cutting concerns. For example, the locking identifier that I quickly talked about, they can basically specify that you have to attach a certain metadata to all of the commands or to property calls. And for example, for the locking controller, it's a lock identifier. For authentication, that would be an authorization token. And then, so therefore, you have to do a bit of mix and matching. Like, okay, for this call, this is the request object, and then I have these three kinds of metadata that apply to this command, and I have to put values there as well. So there's a bit of that's the one extra mile that you have to go if you want to set up such integration, because you also have to know what metadata is actually applicable. Because what we also developed at Tecan is that we have, for example, also a feature that basically gives you, I mean, the interface of a feature is very procedural. So it's really a set of methods, basically, or a set of properties. And if you want to turn this into a more object-oriented way, it's as simple as just putting an object identifier as metadata to it. And then you have a feature that also tells you, okay, which objects are available for this feature. And then you can basically demand an object identifier for each call. And suddenly you basically create a gateway. But this is also a nice thing that you can basically extend such features like that you have a server that is actually a gateway to represent many devices. You can implement that quite easily within the feature framework. The only thing is for such features that add metadata to all of the calls, this is something that the clients need to be aware of. Because, for example, authentication, how do you get the authorization token? That is defined in the feature, because what you do is you basically log in, and the login gives you the authorization token that you then have to attach to all the requests. But this is very specific to the actual feature. For example, the locking server, you would have to lock the server first, and then you have the lock identifier. But you actually can create the lock identifier yourself for the authorization. The authorization tokens created by the server. So it's very feature specific. So for those kind of viral features, you really have to have an idea which of those you actually support. Because otherwise it's getting a bit difficult. But yeah, for kind of, I mean, the normal case is really that the device basically says, okay, I have this and this capability, and this is the set of commands and properties. The use case for these client metadata is rather limited to cross-cutting concerns, and you basically have to know those cross-cutting concerns quite well, but you don't, with the dynamic client, you don't really have to know the kind of standard features. If that makes sense.
It does.
Okay, that's good.
Okay, thank you very much, Georg. I think that was very, very nice. And also the discussion about the dynamic client and also the orchestration. That was also a very good question from the audience. I think it's an important aspect. Do we want to move on to the Python repository?
Daniel, can you hear me?
Me, yes.
Okay. Can you just change me to presenter mode?
Sure.
That I can.
So which one are you? I have Mark Dörr.
The first one. The first one next to Thomas Thaler. So the upper one, upper left.
Different one. I have Mark Dörr and Mark Dörr Web.
The web one.
Okay.
Because I'm using using the tablet for the communication.
Yeah, that's fine. So you should be presenter now.
Yeah. Perfect. Okay, it works. You see both screens now. 1 second. Okay. Do you see my screen?
Yeah.
Because I don't see anything in the.
I see it. You're sharing your browser currently. We see that.
Just the browser. Yeah, that's fine. So do you see the Python? Yeah, now it's working. Good. Perfect. My name is Mark Dörr from University of Greifswald. I don't know if the introduction worked, so I quickly tell a few words. I'm responsible for the Python repository, which is a little bit different in structure than the C# repository, but we try to merge or come together as good as possible. So our repository is structured, I hope, very easily, very simple. So we have the documentation, and this documentation can be seen also here. If you just click on the docs button, then you have a very nice introduction into the installation, a quick start tutorial, some specific tutorials about different operation systems, and then also how to make your first client server. This is all in this documentation with a lot of links. So this is in this docs folder. And then the next folder we have are examples. And here these are featuring different aspects of SiLA. So that you, if you have just want to learn a little bit about one or the other aspect of the SiLA implementation, then you can have a look there and just see something that is very focused on this particular problem. Just that you get a nice introduction into a good starting point into these different aspects. By the way, here's also a Jupyter Notebook client Daniel just mentioned. And then there's this implementation folder. The implementation folder gives some example implementations from real life devices or real life problems like barcode reader, or right now the most developed one is a temperature thermometer or temperature controller. We are also going to implement some pumps. Some of the more of your help to implement it, but it shows a little bit, points into the direction where we want to have it go. And if you have some more examples, like if you, for example, are developing or make some nice small device implementations or implementation of a useful feature, then please contact me, and I will also add this to this list here of implementations. So it's basically implementations that are also coming from real lab environments, just to make to show more complex behavior than in the examples. The Raspberry Pi repository, Raspberry Pi folder, it's just explaining a little bit about the installation of Raspberry Pi related stuff for SiLA Python, that you can just run your developments on a Raspberry Pi or connect to a Raspberry Pi. Then we have the release tools folder. In there, this is executables for us. I mean, for the maintenance, so it's more for releasing new versions of the of Raspberry, SiLA Python. And then very important is the SiLA library. This is in here. Here's a folder called SiLA Tulip, and this is the core library of our server and client classes. So in here you see the SiLA client and server class implementations, and all your classes you can be derived from these base classes. And in here are also a lot of helper libraries for example, for managing the framework, the SiLA framework. We have a proto buff compiler, so we can convert the XML format, feature description language into protobuf language, and then generate the stubs Daniel and Georg mentioned. This is then we have error handling. These are the most important parts of the SiLA tooltip. So these will be used in real implementations of your examples. And then I'll go back just a second. It's a little bit, then the network connection is quite slow here. Yeah. And then SiLA tools. This is also very useful. In here, just 1 second. Comes up. There's the SiLA code generator. So this SiLA code generator is a tool to help you to write your first code. So what it does is it takes features format. So you collect all your features you want to implement in one folder, and then and then you run the SiLA code on this folder, and it generates all the code, the Python code that is already executable. So you can run it, but it has not like a real life connection to devices. So the only thing you need to fill out then is adding the real life hardware connections, like the COM port commands, communication, or the CAN bus commands. But at least you have the full structure of your server and client. So you can already see how it should look like, and a lot of code is already generated. And the only thing you need to do is you need to fill in the hardware specific parts of that. So it's a good starting point for developing, and a very fast starting point for developing new server and clients, because you can just design your features, compile it with a SiLA code generator, and have already a good starting point for in a runnable client and a server structure. So this is this, and then so yeah, this is basically the structure of the SiLA tools. We have, and then to the repository, we have here in issues milestones, we have a plan of what we will do in the next weeks and months. So we have a clear, what to say, time schedule for implementing it. Right now, we are looking for motivated Python developers. So our group is rather small, so we have 3 to 4 active people that help implementation, help to implement. So we need some more manpower to cope with all this, or to implement all what we planned. So if you have some spare time and motivation, please join us, and then you can add your code in here. We also would like to have some feedback from you. Just it's also very important for us to see if the code by itself runs, or if you have trouble with it, and we try to fix these problems as soon as possible. The lucky situation is that in the next weeks I have much more time than in the last month, because I'm
Mark, we lost you.
Oh, good, it's not me.
Why? Is it usually you?
Is it? Am I back? Do you hear me?
You're back.
Yes, I'm up.
Hi.
Good.
So when have you lost me?
Just now.
Okay, so that's fine. Okay. Strange, yeah. So so if you are please just contact me in case you have questions, and I'll try to help as quick as possible, because right now I'm in this lucky situation that I don't need to teach for the next 2 months too much, just a little bit, so I can be quite reactive now. Yeah, and if you have any questions, please, I'm now open to hear what you are interested in. Hello?
If there are no questions, I mean, we know that this online meeting by no means compensates for what we could have done in the hackathon, of course. But still, I hope you got an impression what SiLA is, why we are doing what we are doing, and where to find a head start into the repositories. So I would suggest really feel free, join the Slack channel, read the wikis, try out stuff in the repositories, and most important, please register for the next hackathon once maybe this Corona, which I don't make a comment on, is finished. Yeah, we are all of you who are maybe biologists in the call or so, you probably know that this is stupid, but now I made a comment already, sorry. Yeah. Maybe next year we could close all the exhibitions and everything with the next influenza. Maybe it would make about the same sense. Yeah, I heard that even analytic. Yeah, sorry, go ahead.
No, that was the second comment that you made. You didn't want to do one.
Yeah, I know. I can do a third one.
Go ahead.
The third one, which is really also getting on my nerves, is that very nice events, such for instance like Analytica, will be cancelled and postponed, which I really find a pity. So third comment, sorry.
So I didn't know. Okay. Wow.
Yeah, it on Monday will be communicated on Monday, unfortunately. So. Yeah, but regarding SiLA, so I mean, I recorded the session now. I'll check afterwards how to make that available. Otherwise, I mean, still we have maybe some 1-2 minutes or so for questions if you have. Yeah, if this is not the case, I mean, I really appreciate the many of you who participated, and I hoped it helped. Or maybe you can comment quickly. Did it help you? Was it like kind of expected what you have seen, or did you miss an important point?
If no one wants to go first. I actually thank you for sharing the slides beforehand and being very open about the slides. So I took a look at the slides before already, but it's always something completely different if someone walks you through the slides and points out the important things. So I think all three of you did a good job there. So it met my expectations. Thank you.
Thank you very much.
Thank you.
Good to hear.
From my side, also, thank you very much for the presentation. I really appreciate it. And I have one question. So you're talking about basically making everything online publicly available, what you code, so not by force, but optionally. How about GMP and GLP standards if you work with such a thing? So let's say I have a GMP implementation of my Sartorius balance. And now I see there is a GitHub or GitLab update, which really makes the balance better. I don't know, response times down or availability up. how can I pull it into my already certified environment? Is there any process that you are offering or that I can link into to make it available?
It's a very good question. I think Julian, right?
Yes, Julian from PSF.
Yeah, it's a very good question. So there is two things to that. So first of all, the repositories and the code and everything, and also process about updates and software products, etc., is not the business of SiLA, right? So the SiLA standard does not define anything. If your example of Sartorius, if Sartorius offers a SiLA interface and the SiLA interface needs to be upgraded or whatever, and if Sartorius sells this as a product, it's actually Sartorius' responsibility to maybe provide documents for installation qualification. But it's still your responsibility as a user to do the operational and performance qualification, right, in a GMP area. But of course, the SiLA standard has still a small, but it has a chapter about GMP, GLP in Part A, which basically it provides certain things, like for instance, access restrictions by authentication and authorization features, for instance, by encryption and all these things, to be able to implement your system in a way that data integrity is guaranteed and that it can be validated. Still, it is always your responsibility as a user to create the user requirements and validate the user requirements. You can never, ever delegate that to a vendor. And of course, if Sartorius is using the SiLA Git repositories as part of the implementation, Sartorius needs to have appropriate quality measures in place to validate that basically the quality of the code repository is okay and suits their quality standards, right? But this is not something that SiLA can do anything about it, right? So I don't know whether this, but also these GMP things, it's not like a certification, it's not like ISO, right? You can't certify your product to be GMP compliant. You can't do that. You can only validate a system once it is implemented at the customer place, and it can only be done by the customer. A vendor can never sell a validated product, right? It can maybe sell a qualified product, but not a validated product. But
maybe as an addition here for TCAN, because we are a medical device company, and you could maybe think that also the TCAN SiLA SDK has been developed using the TCAN processes, but that's actually not the case. Only it's just a prototype for us. So of course there are some quality gates also in place for the open source repository, but this is not officially following the TCAN development processes internal. For us, it's at the moment just a prototype. Yeah. So you can't really expect any certification or quality gates there. No formal ones, at least.
Yeah, I mean, we put effort, if you talk about the SiLA repositories, we put effort into a continuous integration and development pipeline into
but they are only informal tests right now.
Informal,
so
exactly.
You won't find any formal tests in any of the repositories.
Exactly. And if you, as a software vendor, maybe if to stay at the example, if Sartorius, as a software vendor, is offering devices with SiLA interfaces, and Sartorius writing these SiLA interfaces, but relying on the Git repositories. I mean, it's Sartorius' job and Sartorius' quality management system who has to guarantee that the code that they do and the references that they make to any third-party libraries are, of course, matching quality standards. It's the same always for any open source library you in the end. But there's no general statement you can make regarding GM compliance or so regarding of the open source repositories. Of course, I think we have an interest in maybe not only informally, but also more formally testing or kind of qualifying that the code in the repos stays on a high quality level. But as Georg just said, currently it's informal, and we try to add regression tests as much as we can, and also to keep the quality standards up. Currently, it's also a big responsibility for the maintainer of each of the repositories to keep quality standards. Yeah, but this is, I think, all we can say about that, and I hope it kind of clarifies a bit how we think. Or Julian, did it answer your question so far? Are you satisfied with that?
Yes, that's actually what I expected. So it's your system in general is able to be qualified, so you have that in mind. But the ultimate responsibility is, of course, on the vendor and user interface. That was clear. But my question was basically, is it, if I'm using it as is it still able to be qualified, or is there something major flaw in the way which says, okay, if I use SiLA, I will never get a qualification? So in general, it's possible, but it's you have the grounds for it, but the actual making is vendor and user specific.
Yeah, actually, Julian, this is a very, very good summary. Thank you. This is exactly the case.
Daniel, just one last point from me. I don't know if it is stated somewhere in the slides, but we should mention the option of Slack channel for upcoming questions that can be quickly answered.
Oh yeah, that's a very good point. You don't have to send emails or so to us. There is actually in the wiki, I think there is a link to register on the public Slack channels. Please use that. I think you usually get answers very quickly if you post anything there, because the community is quite active. Yeah, good point, Stefan.
And you have separate channels for each of the repositories, and the general channel for general questions, and yeah.
Exactly. Okay. Very good. Yeah, so if there are no additional questions, I really thank you very much for your attention and your interest. Feel free, use as we said, the channels to communicate with us. I mean, you can also send formal emails to Carmen if you want to know more about the organization, if you're interested about memberships and things like that. Please also just feel free to do that, or reach out to any of us, Georg, Mark, Stefan, Robert, Sebastian, whoever is active in the SiLA community. I think everybody's really open and responsive. And as I said, I really very much look forward to meeting you in person in one of the next events. I think the next event, if I'm right, will be at Roche in Basel, I believe. And then one more. Sorry,
Let's see.
Let's see. Hope that it will be May. Hopefully in May it's over. And in June, I think there will be the next event in Berlin. And after summer break, there will be an event, I think, Georg, at your place, at TechCon in Wiesbaden. And there will be an event in the Netherlands, which is not yet completely fixed for the date, but it will be. And there is also an event in the UK, which is planned. There is an event in the US, which will be later in the year. So, yeah, stay tuned on the website. Okay, thank you very much. Have a wonderful weekend, and yeah, enjoy, and talk to you soon, hopefully.
Yeah, thanks a lot.
Thank you very much.
Thank you.
Yep.
Bye-bye. Bye-bye.
Thank you very much.
Bye, everyone.
Bye.
Bye.